So myself and Anna, we're both at Rolls-Royce PLC within the Civil Aerospace division. We'll be talking to you through today the step-by-step process in running a project, right through from deciding who your customer is, through to actually delivering the project and writing your instruction manuals. So we'll give you a couple of tools you might be able to use as well, and we'll use an example throughout, which you might be able to apply to your projects as well. So next slide, please. So a little bit about me. So I'm a design engineer in the civil aerospace business. So I work on designing large engines for wide body aircraft. So I studied master's degree in mechanical engineering, and I now work in designing with our external partners, our components, making sure that they manufacture them to the correct quality and to the correct delivery. It's a really exciting role, and it's an excellent industry to be in. Really exciting at the moment as we're moving towards electrification of flight. So I'll move on to Anna to let you know a little bit about her.
Hi, I'm Anna. I also did a master's in mechanical engineering, and as James said, I also work in civil aerospace. So at the moment, I'm working as an engineering program controller within the tooling team. So I look at how the design of our physical tools and how that ties in with the methods to create new ways to service and overhaul our engines. It's also a really exciting place to work. One of the key areas that the company's focusing on at the moment. So dive right into it. When you come to start a new project, there's kind of 4 key steps you want to consider. So I've displayed them here quite linearly. So you've got your understanding of your project, designing it, making it, and testing it. Now, the very natural thing that everyone wants to do is jump right in and just start designing, start manufacturing, and have a thing that you can show people. What we generally recommend is that you spend a little bit more time early on just understanding a project. So who are you making it for? What are you trying to solve? The best ways to go about it. There's tons and tons of factors that we'll take you through in this presentation. And the reason we say you focus on this first and dedicate that extra time to it is because you can get halfway through a design process and then suddenly realize, oh wait, actually, this isn't the right thing. This isn't doing what we want it to do. And you have to start all over again. And you've used up quite a lot of time, maybe some of your budget, when if you just spent that extra week early on, you would have had a much smoother process. Same goes for manufacture. And again, you might not realize until you're testing it that suddenly it doesn't have a key feature you wanted. So spending that extra time early on, really, really beneficial. And like I said, I've shown it linearly here. In reality, you might get halfway through make and go, actually, these components don't fit together quite as easy as we wanted to. We're going to go back to design, or you're testing it and something's not quite right and you want to go back to your manufacturer. So you can jump back and forth a little bit between these as well. Don't feel like you have to do it very, very rigidly, and once one's finished, you can never look at it again, because it's absolutely not the case. So as James said, we're going to be using an example to kind of take you through these tools. So first question you want to ask when you're understanding a new project is, what problem are you solving? Right? What is it that has meant that there is something people want? What do they not currently have? So the example we've got here, this person really wants a cup of tea, but they've hurt their arm and they struggle to make it themselves. Maybe they've got tennis elbow, it really hurts to pour a kettle. And they're just sat at home on the sofa trying to recover from their injury, but they can't make the tea to help them do that. This person's at a friend's house and the friend's offering a cup of tea, but they know that friend doesn't make a very good cup of tea. It's always too milky, not strong enough. And then we've got another person who just doesn't really fancy making tea. They'd love to have a cup, but they don't want to go through the effort. So the solution we have come up with for this problem is an automatic tea maker. And that is the example we'll be taking you through today. So to start with, fancy name for this is a work breakdown structure. In simpler terms, what tasks do you need to do in order to design the thing that you're designing? So what do we need to do to make it an automatic tea maker? One of the best ways I like to do this is get everyone in a room, get some sticky notes out, and everyone just writes down tasks. You can do that while talking to each other. You can do it in silence and talk about it later. But the key thing is, at some point you need to talk about it and everyone bounce off each other, and you can come up with more ideas because of that. So what we've come up with here is you want to define your requirements. You want to know who's involved in the project. Writing probably some code for the Raspberry Pi stuff you're working on. You want to come up with ideas to meet your requirements. There's little bits of design, so the casing electronics. You also want to build it, you want to test it. If anyone has any other tasks you might need to complete for a project, if you want to just pop them in the chat now, and I'll give you 30 seconds to do that. Costings, yeah, you want to consider your budget and what the breakdown of that would be. Any others? Sustainability, very important. And then, yeah, you're going to need a spec. That's absolutely right. Something I've entirely missed. You could consider a spec being part of defining requirements, and sustainability could come under that as well, but it could easily be a separate task. It's really dependent on the project, and there isn't one right way to do it. So once you've got this work breakdown structure, you can categorize it. So here I've picked the 4 things I showed you earlier. So understanding your project, design, make, and test. The way I like to do this is color coding. It just makes it really clear, really easy to see. So you can glance this, have it up on a wall or on a whiteboard and see, oh yeah, there's 4 design tasks there. And perhaps you could tick them off. You could take down post-it notes after tasks are done. It makes it really clear to see where you are each stage of the project. And it's just a very nice visual method to help the team understand what needs doing. Next thing you want to know is who does your tasks. So in this hypothetical team of 6 I've got here, the roles I've come up with are project manager, your design lead, your manufacture lead, programming lead, electronics lead, and marketing lead. So these are kind of what I was considering as the key areas of the team maker example. The project manager is going to have a sort of oversight. They'll be dealing with your project timeline and your budget and things, as well as having a general idea of how everyone's doing. And then the others are all fairly self-explanatory. They're leading those areas. This doesn't mean that's the only thing these people work on. So your design lead will need to talk to your manufacturer lead, because there's no point designing something if there's actually no way to physically make it. They'll also both need to be talking to programming and electronics to make sure you can fit your electronics into whatever it is you're making. There's not going to be any kind of interference going on. Your programming needs to line up with your electronics. You don't want to program for a component that you're not going to put into it. And then marketing is maybe dealing with more of the kind of, in the example, the case you're doing is your presentation, any like leaflets or other materials you want to produce to go with it. And as well as talking to each other, in a really good team, you'll all be supporting each other in all of these areas, feeding into each other, being able to discuss. It's not a good team if you're completely siloed. You really want to have a view of everything that's going on, even while you are mainly considering your one key area. So we've had a really great point in the chat. They've done something similar and found students' roles a little restrictive. Yeah, that can be the case. And that's why I say that while this is your role, you absolutely should be looking at other things. You can say, yes, I'm the design lead, but I understand what's going on over there, and we've had that conversation. And just because you're the design lead doesn't mean you're the only one making decisions about the designs. So the next thing, you know what you're doing, you know who's responsible for what. So you kind of need a project timeline. How are you going to fit this in? So this is what we call a Gantt chart. You've probably seen something very similar to this before. I've broken down the tasks from earlier. So starting off with defining your requirements, that's number 1, super important. You can't do anything until you know what you're doing. Then generating ideas and choosing your best ideas. After that point, so I've got a couple of things happening concurrently. So you can design your casing and electronics sort of in tandem, and you can start writing your code at some point in that time as well. There's nothing that says you have to design one thing and then the other. You could even really start making some things. If you have a design area of your design that you absolutely know is not going to change, maybe it's a bought out part that needs to connect something in a very specific way, then you could make that part. There's nothing stopping you doing that, provided you're aware that things might shift and change as you go through the project. Testing code as well, I've got overlapping with writing. Generally, code, you sort of write a bit, you test it, you write a bit, you test it. And then once you've built it all, you want to test your whole thing, your final product. And there's a little bit of time at the end for making some improvements as well. Because as much as we'd love to, you're probably not going to do it perfectly the first time. So now on to James.
Okay, so once you know a kind of high-level view of what's going to be happening in your project and what those key tasks are, it's important to think, who are we actually solving this problem for? So we go back to the automatic team maker example. We want to think, who's going to be using it? Will it be used by businesses? Will it be used at conferences? Or will it be used by household consumers? Will it be used in the kitchen by a family? So some examples to think about is our customer going to be a tech enthusiast? Are they going to want a tea maker that's got all the bells and whistles, that creates it in under 10 seconds, or are they going to want a tea maker that's a little bit more cost effective, that can do it in a little bit more time? So someone who actually really wants something to look really nice, or it's something that just does the job. So start thinking about who your customer is. Is it going to be someone who actually has a disability, who's unable to use a normal kettle? You might start designing it a little bit more ergonomically around that. Also, what setting will the product be used? So will it be used in conferences with 100 or 1,000 people all needing a cup of tea within a half an hour space? Or will it be used just in the morning by one person on their own? So all these things are really important to think about when you're setting out at the start of your project. So the next thing you've got to think about is who's going to be involved. So in industry, we call this stakeholders. So a stakeholder is someone who's affected by the decisions, activities, and outcomes of the project. So what we want to do is a stakeholder analysis. So we need to decide who those people are. So the first one might be the customer. So who you're designing it for. Manufacturer, who's going to be helping you to make it and supplying the products. The project team, everyone who's actually doing the work yourselves. Competitors, are there any other products in the industry at the moment that actually might do similar role, that you might be able to take a few good ideas, provided you're meeting the copyright requirements and everything, obviously. Service and maintenance, is there going to be a need to maintain the product after? Is it going to need to be serviced every 2 years, etc.? Investors and sponsors, when you get over to the business side, if you're trying to build a business case, it's important to build that up to a presentation that you might need to provide to your investors and sponsors. And finally, marketing and sales, how are you going to market your product, as well as regulators. Are there any regulations, such as safety regulations, that you have to meet? All these people are people that are stakeholders in your project. You've got to be thinking about them as you go through your project and as you go through those project steps that we previously mentioned. So the next thing that you might want to do is, what could go wrong? So think about the risks, whether it be product risks around what you're making, or the project risks about how you're making it. So it's really important that you think about what are those real sort of high risks that we've got to put in actions right at the start to stop them from happening. So you don't want to get to the end of the project and find that suddenly a critical component is suddenly broken and you don't have a replacement. So what you might decide to do is what's called an if-then analysis. So to break that down, going back to the automatic tea maker, you say, if the thermal plate fails, then the water will not boil. So it will not meet one of those key requirements. If a team member is unable to work, then the key task will not be completed. So this is a project risk. So some of the key work might not actually get done in time. If the water tank exceeds pressure limit, then the tank could explode. So this will be a safety risk. So putting all these if-then statements together will really help you at the start of the project decide what those key risks are, and then you can put them into a proper risk analysis using a risk assessment table. So we've got an example there. So where we've got the likelihood on the left-hand side. So how likely is it to happen? Is it definitely going to happen? We're definitely going to see this throughout the project, or it's really unlikely to happen. It'd be a 1 in a million chance. Against the severity, it's the impact of it happening if it does happen. So the ones in the top right there, we've got high impact of it when it does happen, and high likelihood that it will happen. So we've really got focus on putting in actions to make sure that those don't happen right at the start. Whereas in the bottom left, we've got low likelihood of it happening. We've got low severity. We can kind of might even ignore those. And then even in the corners, we've got low severity, but high likelihood. We're probably going to want to think about what we can do about them. And equally high impact, but quite a low likelihood. We've got to think about actions that we can do right at the start. So you might find this as a useful tool right at the start of the project that you can do as part of your overall submission to show that you've thought about those things. So what does the product need to do? So we call this requirements gathering, making sure you know exactly what the requirements are for your product before you embark on that design and that manufacture. It'll save you the time down the line if you actually know point by point in detail what the requirements are. So we've got a picture here around requirements for a swing. So we've got how the customer explained it, how the engineer designed it, how the project leader understood it, and how the programmer wrote it, all completely different because they focus on different areas. But actually the customer really needed something that swung, that was fun, and had minimal parts and was easy to make, just to tie it on the tree. So it's important to decide what those product requirements are and what the project requirements are. So going back to the automatic tea maker, the product requirements would be the product shall boil the water, so up to 100 degrees C. The product shall brew the tea. So we don't just want it to brew for 5 seconds long, so it won't be a nice cup of tea. The product shall be able to make tea to the customer's taste. So add the milk, add the sugar, whether it's 2 sugars, black tea, etc. The product should add the tea automatically. So at the start, we've defined that one of our requirements is automatic tea maker. And the product shall be safe to use in the home. Again, safety requirements. When it comes to project requirements, it'll be more around we've got to do it tasks by these certain dates, and the overall project shall be completed by, in this example, it's Monday the 21st of March 2022. So if anyone's got any other requirements, please just do put them in the chat and we'll come back to them. So when it comes to, when you decide what those requirements are, you might decide to use a sort of solution analysis, or in industry we call this a function means analysis, but it's a bit more of a technical term. So you put down your requirements on the left hand side there, and then you've started to think of ideas of how you might meet those. So for example, in idea 1, we're saying that we want to boil the water using a laser. We're saying that we want to brew the tea using tea bags, and we're going to add the tea to the cup using a funnel, and we're going to add milk and sugar being sort of spring loaded. Whereas on the other side, we've got idea 3, we can heat up the water using compost tea, we can brew the tea using instant tea, we can add it to the cup with a hamster driven wheel mechanism, or we can add the milk and sugar just using gravity, releasing a mechanism. So these are all different ways that you could get to the end products, but it's important that you sort of brainstorm these out and just go through all different possibilities, as the end solution might not be something that you would expect, even though it meets the requirements, and to the main sort of drivers, which we'll discuss next. So the main drivers for deciding how to narrow these down, the first one is often safety. So we can start crossing these out. So it's not going to be very safe to fire a laser at it if you're in a domestic kitchen or in a conference. It's not going to be very safe to have an open fire, so we can cross those out straight away. Next, we might decide to think about cost. So I know pods is a massive thing in coffee at the moment, but not so much in tea, as tea bags are often considered a lot cheaper, a lot superior. So we might decide to cross those off. Also, an automated spoon might be a lot more expensive and a lot more complex to do the simple job of just adding milk and sugar to the cup of tea. So we can cross those out. When it comes to ease of use or userability, it might not be very practical to have a hamster-driven wheel. The hamster might decide to jump away and run away, it might run too fast. It can be very frustrating for the user, so we'll cross that one out. And finally, when it comes to user experience, customer experience, we'll think about what's it actually going to be like day to day for the customer using this. So we can cross out compost tea because it might be quite slow, it might be quite smelly in the kitchen, and we can cross out instant tea, as at the end of the day, it might not taste as good as the tea bags or the tea leaves. So this is a good way of just coming up with your requirements and actually crossing them out just to show that you've thought about all different options. I know in this example, we've gone a little bit extreme, but there will be, it's a good way for you to use in your teams to narrow down those requirements. So handing back over to Anna.
So you've got your requirements. Now you've worked out which of those ideas meets your requirements best, basically. So I think James has already covered a few of these. Does it do what your customer wants? Does it actually meet the requirement, or is it a really cool idea that maybe it's not going to be great? And there's no such thing as a stupid idea. If someone comes up with something in a brainstorming session, write it down. It can absolutely trigger other more feasible ideas. But you might end up ruling out the silly ones later on. You need to look at how much it will cost. Can you actually manufacture it? There's so many things that humans would love to be able to make, but the manufacturing capability either doesn't exist or just isn't in the budget of the person who's had the idea. Can you do it in time? Is it going to push back your project schedule if you need to spend an extra month looking into this one system, which may or may not work? Again, is it safe? And are you confident it will work? So coming back to the example of the laser heating the water, it'll be really, really quick, but it'll be expensive, probably not practical for your average day-to-day user, and not going to be particularly safe from kind of an eye safety perspective. You have to wear sort of laser protective safety glasses every single time you want a cup of tea, and that's just not very practical. So one way we can compare these ideas is what we call a Pew matrix or a comparison matrix. So in this example, I'm going to take a kettle and tea bags as kind of the baseline and compare everything else to that. So obviously kettle and tea bags is what the average person probably uses day to day. And I'm going to compare it on a range of different criteria. So if you see concepts 1, 2, and 3, some of the boxes have a -1 or a -2. So if it's -1, it's not quite as good at that, and -2, it's really not as good as the kettle. If it's got a 0, it's about the same, or +1 and +2 for a little bit better or a lot better. So when you look at concept 1, you can see it's not as durable. It's not going to do quite as good a job. It's really, really cheap. Maybe not as safe as a kettle, but it's easy to use. It's just as easy for you to manufacture, and it's really cool. So it's a little bit better overall than kettle and tea bags. Basically, you sum up the numbers in that column, and that number at the bottom is kind of your overall score relative to your baseline. So that one being really, really cool might actually be a nice idea if you were, for example, marketing to tech enthusiasts. They're probably slightly less fussed about durability, and we all know someone who will buy a prettier laptop because it looks pretty, where it's maybe not as fast as another, so the performance might not be as much of a factor. If you look at concept 2, it is more durable than a kettle and tea bags, and it performs slightly better, but it's more expensive and it's not particularly safe. And safety obviously being a key criteria, you could decide just on that factor that you don't want to use whatever elements of that concept make this unsafe. Concept 2 is, however, easy to use and cool, not quite as cool as concept 1, but it's more difficult from a manufacturer perspective. So that comes out at -2, so worse than the kettle and tea bags. You may have already guessed where this is going with concept 3, by looking at the numbers at the bottom. So it's really durable. It does a better job than the kettle and tea bags. It's cheaper. It's no less safe. Really easy to use, really easy to manufacture, and it's a bit cooler as well. So we've come out as a +9, and in this context, we would probably choose concept 3. If you do this and they all come out about the same, there's not much to distinguish between them, you can absolutely mix and match between concepts and say, well, we really like this element of concept 1, it did really well. So we're going to take that and add that into concept 2 to make it better. And that's absolutely okay. You can use this as a tool to help you identify what it is you have contributing to each of these factors. And you can also use it to identify things that might not work together quite so well. So I think on the functional means analysis, we thought about having a tea bag and a funnel, but a tea bag probably won't fit through a funnel. So that's something you need to consider as well. Then when you go into your manufacture and test, so various factors to consider here. You need to make it strong enough so it won't easily break. This is true for, I think, most things. So you could probably, most of the things can be out of plastic or wood. You could make it really, really strong. Use, for example, diamond. But that's going to be very, very expensive. Probably quite heavy as well. So it's maybe not the best idea for your next door neighbor to have an automatic tea maker made of diamond. They're not going to be able to afford that. It doesn't really make sense, especially when something like wood would do the job absolutely fine. When you come to writing up instructions, you want to make these really, really easy to follow. So there's loads of examples in everyday life. We've got some Lego instructions on the slide here, and they're great because it shows you the parts you need for the step and what it looks like once you've done it. And you can also borrow a phone back, see what it looked like before. So it's very, very easy for absolutely everyone to understand. IKEA instructions are another great example of this. And then once you manufactured it, you also need to test it. So I know we've written, give it to your friends to try and break. This doesn't necessarily mean physically break. This can mean you're pressing too many buttons and the system gets a bit confused. In some cases, things like if you were designing a phone case, for example, you might want to actually physically break it. You might want to see, can that phone withstand it in that case? But for most projects, that's not really going to be your ultimate goal. You just want someone at a similar level of understanding to you to sort of just check your work. And then you also want to check that it does what you've required it to do. So we call this user acceptance testing. You'll generally get someone who might be an end user. So it doesn't have a whole lot of knowledge of the work you've done up to this point, but that they'll have an understanding of how the product will be used in everyday life. So this is something that's very commonly done for things like apps, where they'll give it to someone who might use an app, basically a load of steps follow through, and it'll say, when you click on the app on your phone screen, does it open? Yes, good job. make it really, really kind of granular, break it down to really fine levels. And just when you click this button, does it do this? And it's actually really important to do that kind of testing, because you'd be amazed at the number of things that can crop up.
Okay, yeah. So what do you do once you've made your product and you've tested it and you're pretty happy with the results you're getting back? So it all comes around to sort of the project closure and the project summary. So I know on here we've written write a report. That's not a requirement for this competition, but it might be something that you decide to do in your teams. You want to do your build instructions. You want to make sure that they're clear, as Anna just said, that anyone could read them and make the product that you've suggested. You're going to want to bring this all together in a presentation. So you want to tell the story that you've been through throughout the project. So how you decided on your current concepts, how you came up with your concepts, how you defined your requirements, any risk analysis that you've done, any plan that you've put together. Put this all in the presentation. Try and make it simple as possible, but tell the story. It's also really important to make sure that you define the lessons learned. So what have you learned in the project? What would you do differently? So if there's certain things that you would have done differently if you did it again, make sure you talk about them, because at the end of the day, this is something that we do in industry. No matter what project it is, something incredibly complex. Lessons learned is really, really important, especially in the aerospace industry. What would you not do if you were to do it again? What would you have done? What was a bit of a waste of time that didn't really add much value to the project? Talking about these things is actually really important. It shows your understanding of what you could have done differently and what you've actually learned at the end. So next slide, we'll talk about the presentation itself. So in your teams, it's really important to think about how you're going to present what you've done, because it's going to be difficult to summarize it all just into a few slides, whether it be a 10-minute presentation or a 20-minute presentation. So try and summarize it in as few words as possible and keep your slides as visual as possible. So something that some people try and aim for is to aim for 6 words a line and 6 lines in total. Use a large font where you can, and use pictures where you can to explain what you've done. So it's going to be really important to show pictures of the product, pictures of it when you're making it, maybe any designs that you come up with. Make sure it's visual as possible. Try and minimize the number of fancy stuff moving around the slides. If it adds value to the project, I think it does actually add to the presentation, add it in. But don't make your slides too visual. It's too difficult to concentrate on. Make sure you try and keep by the KISS rule, which is just keep it super simple. And make sure you practice. It's going to be really important, especially if you've got a time limit on your presentation, that everyone in the team has done a lot of run-throughs and they all know how long they've got to take on their slides. Finally, make sure that you try and speak really slowly. Actually, actively try and be slow, because everyone naturally speeds up when they're talking. So try and be slow, and you'll actually find that you're talking at quite a normal pace. So there are a few sort of things to think about when you're doing the final presentation. So in summary then, we've taught you through some of the tools and processes that we use at a high level from running a project right from the start, right through to the finish. Now hopefully you come away with a couple of tools that you might be able to use in your projects as well.